My name is Armin Ebrahimi. I am the founder and CEO of ShoCard. Today, I'll be talking to you about what we built at ShowCard, a digital identity based on mobile technologies, as well as verification of the identity on the blockchain. What I'm going to do is go over first a presentation that talks a little bit about what the technology is, and then what I'd like to do is run a couple of demos so you can actually get a taste for the technology and how it works. So ultimately what we build with ShowCard is where we see identity going in the future, not just adding band-aids to the old model of usernames and passwords with second factor, but really revamping and redoing how we approach identity. What we see in our vision is to really revolutionize identity across both the enterprise and workplace, as well as a lot of the consumer services. And again, as I said, doing that with blockchain and mobility. The concept behind our approach is to be able to provide something that is more secure, something that actually protects user privacy, in fact, increases the level of privacy that's available, be simple to use for consumers and users, but also have something that could be cross-vertical and cross-border, something that's very different than what we have today in most places. And ultimately work towards a vision of bring your own ID, which is giving the power of identity and ownership of that to the users, something that isn't the case today. If you think about what we are today, for the most part, when we use usernames and passwords, those usernames belong to different institutions. They could belong to Facebook. They could belong to your employer, to your bank. And whenever you leave or sever that relationship with them, you will actually use your identity that you had with them because it really belongs to them. You just are able to access it. As you will see, the approach that we've taken is one where the user actually owns the identity and service providers just provide access. The idea behind our solution is to have a mobile identity on user's mobile device, and users can actually load that up with a few different things. One is access control by having a PIN, something that they remember, also protecting it with Touch ID. It could also be Face ID or any other form of iris scan or biometrics that is implemented by the manufacturer on the phone in order to access the credentials that's on the phone. We also provide facial recognition, regardless of what mobile technology that you're using. And as a platform, we could use other means of biometrics, but facial recognition is what's embedded within the app itself. And last but not least is a government ID, something that is issued by a point of authority, a passport, a driver's license. It could be an employment card or employment information, but something that a point of authority has that identifies the user. And the user loads those up within the app itself in order to be able to identify themselves. And it's a self-declaration of who they claim to be. Now, for a moment, if you think about what we do with our ID information, if you got a passport, if you got a driver's license, is that we go in and we present that to different points of authority. It could be government agencies, it could be banks, airlines, and a number of other authorities, but we typically show our identification. They do a verification of that. And after that, they allow us to have whatever service that we're there to actually request from them. Now, if you can imagine them doing that same exact process that they do today, but being able to create and attach that certification to the person's identity on the mobile device, then you can have a complete identification of an individual where the self-declaration of who the user claims to be matches the certification by a point of authority, and now you can actually have that trust. And the more points of authority that can actually certify that user, well, the greater the web of trust, and this is the true identity of the individual. So that's the concept behind what we have. Let me talk a little bit more about how we do that. So we create that trust through the blockchain. And the process that I was talking about before starts out with the user taking an image of themselves, grabbing their ID card, and we actually have tools to be able to scan it, read up the codes that's on it, and being able to create individual field values for each field of the identity. The image is one field. Their name, address, passport number, driver's license number, date of birth Each one would be a key name value pair. And what we do is we encrypt all of that data, save that locally on the phone, and that way only have to protect the private key. And if someone steals the phone, they won't be able to actually access the data. And that's how we can actually protect that data locally. And then what we do is for each field, imagine the name or the facial image. What we do is we create a one-way hash of the data, and we digitally sign that with the private key of the user on the mobile device. And we repeat that process for every key name value pair. And we create a full record of that, and we put that on the blockchain, and we refer to that as a self-certification. And that's who the user claims to be. And because they've signed everything with the private key, they can go back and prove ownership of that record on the blockchain by signing additional credentials with a private key. So let's say the user goes to a bank and they want to present their data, let's say to open up a bank account. They share their information in order to open up the bank account. That would include their ID information, driver's license, passport, whatever form of information the bank requires. But they also provide a pointer to that self-certification on the blockchain. In this process, the bank actually issues a unique request to the user's app. And that's what we refer to that as a secret session ID. It's a one-time ID that the user gets. And the user actually signs that with his private key along with the data that it's going to pass to be able to show that this is a response to the specific request the bank made. The bank will use the user's public key to verify that it was properly signed, and then goes in and uses that same public key to verify the signatures that's on that self-certification on the blockchain. And if it can do that, it can establish that this is the user that owns that particular record on the blockchain. Now, once it gets the data, it can go through, do the KYC process, verify the individual, and once it's satisfied as to who the individual is, the bank can write a separate certification to the blockchain. The format is identical to what the user wrote. For each field data that the user has actually shared with the bank will go in and write a digital signature of the hash of that data on the blockchain. Now, the only difference is the signatures are signed with the bank's private key, and that record points back to the user's self-certification. Now, by doing this, the user can go in and grab that data. Obviously, it could interact with the bank, and transactionally, the bank can verify all the signatures on the blockchain. But the user can even go to another bank, share the data that he has, as well as the certifications that he got from the first bank. The second bank can look at the data, be able to verify in a very similar manner that the user owns that self-certification. And if the second bank can actually trust the first bank, it can actually look at the first bank's certification record and be able to see that it has actually done a KYC validation of the user and knows who that user is on the first, when the user had first registered with the bank, and be able to proceed without having to repeat the process all over again. So the process speeds up significantly. At transaction speed, the user could verify themselves with that second bank. The user could repeat the process with any other entity. It could be a credit reporting agency. It could be a merchant that wants to verify user's identity, and it will share the same information in the same manner. Each one of these other ones, the second bank, the credit reporting company, the merchant, they can all create new certifications as well and put that on the blockchain. I'd like to go through another quick example to just show how you could share, in fact, additional data beyond the very initial and most basic form of identity. What we talked about was the user creating a self-certification, putting that on the blockchain, and sharing that with the bank. In this case, we're actually showing crediting for one of our customers in a process that they do where they verify the user's ID and they create a certification, put that on the blockchain. Now, credit info can come up with a credit score as well as credit reports and other information for the user. In this example, we just stick to credit score and give that credit score to the user so the user has the actual data. And what it does is it creates a digital signature of the hash of that data and puts that on the blockchain as well. Now, in this example, I'm putting a clear text on the blockchain. That's just for purposes of the example so you could see it, but it's really a digital signature of the hash of that data. Now, if the user goes into another bank, let's say for getting a mortgage, the user can make a claim and say, my credit score is 695. The mortgage lender, in this case, doesn't have to actually directly connect to the credit reporting company, in this case, Credit Info. And what it could do is just go to the blockchain, instantaneously receive the certifications, verify that this is indeed the user who the user claims to be, but be able to also verify the credit score of 695 that the user has given it, that the Credit Info in this example actually issued that. But it could do all of that without having to communicate with Credit Info directly. And that's the important part of it. The two banks could be in two different countries, in fact, and they could still do the same process. There's no additional privacy requirements necessary in order to get permission of the user, because the user is sharing the original data, and the only thing that happens after that is the validation process that happens out of the blockchain. So Credit Info never needs to be able to see any kind of a proof that the mortgage company has the right to retrieve users' data. The security part of it is being able to validate the data instantaneously and independently on the blockchain, being able to verify that the data is correct. Now, part of what we just showed you, and you'll see examples of the product itself, is the idea of being able to have a simple user interface that can read and extract data from whatever form of ID that the user has, driver's license, but it could be a passport, it could be other forms of government ID, military ID, and so forth as well. The other idea behind this technology is that the private information of the user never leaves the mobile device of the user. So we don't have a central database where we will keep the data. And that's how we can protect the privacy. If ShowCard or any other services that provides this is ever breached, the user's private information is not breached because it was always with the user on their mobile device. The other part of it is using blockchain to store these digital signatures of hashes. That's really used for validation. The data is cryptic. There's no PII within that data. And if you're familiar with digital signatures, all you can do is be able to validate that, yes, indeed, this is the party that validated the data and signed it. And the important part of using the blockchain is that there's no third-party trust system. As an example, you don't need to trust ShowCard as a service provider here, saying we store the data and the data is correct. The blockchain itself is you could think of it as an open database, and users' PII is kept with the user provides those, and those are the only 2 points that you use to be able to do the validation, and never a trusted third-party data service provider that goes back and validates the data. Now, this is really the consumer side that I was sharing with you. Real quick, what I'd like to do is talk about the enterprise opportunity as well. One of the areas that we've extended our services to is enterprise login. It doesn't utilize all the facilities that we have, but the core part where users own their own IDs, they carry that with them, and the validation happens on the blockchain is a core part of what we actually provide. Today, security breaches continue to happen. We've seen many of those. One of the largest recently was obviously Equifax. Other service providers, be it banks like JP Morgan to Yahoo to other service providers, have been hacked with millions, if not, in fact, in some cases, billions of records being compromised. And ultimately, even though users have second factors, we're still really relying on usernames and passwords, which is a technology that really hasn't changed in 40 years. And we've added other band-aids to it. RSA cards do provide second factor. There's SMS text messages. But all of those are ultimately band-aids over existing model of username passwords. Now, this is the picture that we have today. Username passwords still exist in the database, and there's a second factor that validates that. And this is what we refer to as being a band-aid. And that username password database is still something that could be hacked. In fact, many of the second factors can also be hacked. The new way that we see is through a product we have named ShowBadge that utilizes the ShowCard technology I was just showing you on the consumer side, and it is significantly more secure. It provides between 3 to 4 factors. In fact, if you add biometrics to it, it would be a 5th factor that's added to that. The user experience is a lot simpler. You don't have to remember usernames and passwords if you're on different devices, but especially if you're on a mobile device in the enterprise space. You don't have to enter your username, which is oftentimes your email address, with your fingers while you're moving around and so on. So it becomes a lot easier for actually employees to use, and it's easier for the IT managers because they don't have to manage the passwords, require users to change them, manage the second factors that users have. If they have RSA cards and they lose them, where they have to replace them. And with what we have, the idea was to be able to integrate with existing standards such as OpenSAML into what is in place today with existing single sign-on services, but change the authentication and really using blockchain so that you can't fake the system. So someone else wouldn't be able to come in and impersonate an employee and log in. Some of the things that ultimately provide that extra security include multi-factor authentication, true biometrics. And true biometrics, what I refer to is not just using Touch ID or Face ID on the phone device itself, but being able to capture original image, certify that on the blockchain, capture a new live image of the user, and really doing the validation on the server side to be able to identify the person. So we never trust a mobile device to provide the data. And there's no central database that could actually be hacked. All the data exists, again, with the user and verification on the blockchain. And the user experience can be significantly simpler. There are no usernames or passwords that are used on your browser. You can access your desktop, cloud applications, enterprise apps, and perhaps what's even more important is on your mobile apps, being able to, again, log in without usernames and passwords and authenticate yourself securely. So that's a little bit a high-level description. You can certainly go to ShowCard.com, both for enterprise as well as consumer space. You can look at a lot more information. We have white papers you could download and get more information on that as well. What I'd like to do next is switch over. I'm going to go back to my browser, and let me bring up a demo that I'm going to run. What I'm going to run for you guys right now is a quick consumer demo, and then if you actually have a chance, I'll try and do that also for enterprise as well. What you see on the right is the ShowCard app itself. I have my driver's license. There's my personal ID card that includes my own biometrics. And what we've done with that is we take a picture of the driver's license, front and back, OCR the data on the front, read the barcodes that's in the back, and we create these name value pairs, and you can see all of those here on the bottom of that screen. And each one of those is what I was referring to before, encrypted on the device itself. I can display it when I'm actually looking at the app, but it's stored encrypted. And the other part of it that's also important is that each one of those has been signed and secured and put on the blockchain as well. Now, I've already registered my ID with the session I'm going to run. This is the POC that we had built that I'm going to be running for you guys. But when I want to log into this now on a repeated basis, what I'll do is I'll bring up my QR scanner. I'm going to be moving my phone. You'll just see on the camera, perhaps, what I'm showing. I'm going to bring that up to the QR code. When I scan that, it's going to ask me to authenticate myself with my Touch ID to log in. I'll use that Touch ID. And with that, it comes back and tells me that my login was successful. And on the left, you'd see that I've actually been able to log into the site. I'm actually going to talk real briefly about what's on here. And then what I'll do is go back and show just some of the other capabilities with this. One of the things that happened in that process was a handshake. We always do that. If you're familiar with the FIDO protocol, we use the FIDO protocol, but we enhance it by doing the validation of ultimately public keys and certifications on the blockchain rather than a trusted PKI or trusted certificate authority. But in that process, in the handshake, a secret was in that QR code. The app actually picked that up. It signed out along with credentials to log in, encrypted the message, sent that out to the city server in this case. It picks it up, decrypts it, verifies the signatures that's on there. And once those have been satisfied, it verifies the certifications that's on the blockchain. And if it's me, then it lets me log into my account. I never had to enter a username or password to get in. Now, with this, I've got a few credit cards that I'll be using those in part of my demo. I'm going to go back here and bring up a commerce site to just show you a couple of interactions, how different parties can actually interact with the identification that I've created, and how we can make e-commerce or other forms of commerce transactions more secure. So I'm just going to go ahead and grab this mug. I'm going to purchase that on the shopping site. I'll add that to my cart. And I'm going to go to my checkout page. And at this point, one of the things that I've got with my ID is my personal information, address, and so on. So I don't need to have those entered each time. I know some browsers actually have form fills, some do and some don't, especially if you go on a different machine. We can actually have a QR code that's part of a browser extension that we can add in. And if I scan that, I'll be asked to actually provide my personal information. And once I do that, the data comes back and pre-fills the form. And I'm waiting for that to come in. There we go. So it's got my name and address information already pre-filled. Now, if I save that and continue on, what becomes a little bit more interesting is the next step. Let me go ahead and save that. Where I'm going to be checking out and making my payments. Again, one of the things that I can do is instead of entering my information, I've got a digital wallet with all my information on it. Again, I can scan that QR code. It lets me pick from the credit cards I have and enter that here. So I'm going to go ahead and save that and share it. And when I do that, the data comes in, and I don't have to enter the data. And one of the opportunities, and we're working with some of the credit card networks to do this, is to change that card number rather than passing a fixed number to actually tokenize that, so the merchant never gets a chance to see the original card number. But what's most important is really the next step. And again, the e-commerce site itself doesn't have to change anything to make this stuff work. Because when I do a place order, I'll get the notification that comes in, and it tells me about details of the transaction that I'm about to perform. And only if I approve all of that, the order is going to get confirmed. So I'm going to use, since I did the transaction, I'll use my Touch ID. I'll approve that. And once I do, you'll see that the order will actually be approved, and I can proceed, and I've got my purchase done. If someone had actually hacked this and stolen my credit card number, I would still receive the notification. What I could do is reject it, because obviously that wasn't me, and I wouldn't want that to go through. Now, I'm going to show you just another quick use case. Instead of a credit card transaction, which is a lower value transaction, what I'm going to do is just show you a case where I'm going to be transferring funds, something that would be of a higher value. So if I go into the account information that I have, and I'll enter those, and let's say what I'm going to transfer is $10,000, and I'm going to wire it from one account to another in a different bank. When I initiate the transfer, I'll get on the screen itself a description of what it is that I was trying to do, and the fact that I'm going to get a notification on my app that's going to require confirmation. On the app, I get the same information, how much I'm transferring, and the fact that I'm required to take a selfie, if you notice what's on the app right here. So I'll use my Touch ID. By the way, each time I use my Touch ID, it gives me access to my private key, and that's why we use Touch ID for that purpose. But I'll do Touch ID. What I'm going to be asked is to also provide a facial image. So I will smile for the camera and capture that. And this is where a higher level of authentication is required. Not only do I have to sign everything with my private key, that's how I access it with my Touch ID, I also provide physical biometrics, which means I'm the one actually sitting behind this phone doing the transaction. And the service provider can determine what level of authentication is required. In this case, it was facial recognition, so that once we validate the initial image, the top image was the initial image, and that image was certified on the blockchain. Then we could look at the second one and be able to tell that that was a live image that I took. It was signed along with the challenge request that the bank sent me, and be able to actually then do facial recognition and compare the two values. And just real quick, if we were to look at my certifications, in this example, Citibank is not the one that actually certified me. The certifier was Bank of America, but Citi, because they can't trust Bank of America's KYC process, you could look at that certification and say, well, based on that, I know who this user is, and I can actually accept the certification that Bank of America had. And one other note here is that Citi, in this case, may have never had my original image, the very base image that's on top here, because that was only shared with Bank of America when I was certified. The data is actually shared from my phone, both the original image and the new one, but the original image is validated on the blockchain to say, yep, indeed, this is what was used for the initial validation of the user. Actually, I apologize. I'm looking at my phone and I see a lot of the details, but when I look on the phone, it seems like the screenshots have frozen, so it wasn't navigating with me. So I described parts of it. I don't think you were able to necessarily follow what was happening on the mobile app itself. Perhaps what we could do is open this up to questions, and maybe I could answer some questions, and if there's things that I could show with that too, obviously I'll do that. So the other question was, what blockchain did we write to? And the architecture is designed to be blockchain agnostic, which means we can write to any blockchain. With our interface, you can actually specify Bitcoin, Ethereum, as well as Blockstack. So we write through those. Blockstack writes to several other blockchains as well. We can also write to privately permission-based blockchains as well. The reason that we did that is twofold. One, initially we started out writing everything to Bitcoin, and as Bitcoin has been getting more and more usage as an investment tool, it's gotten backed up a lot more, and transactions take a lot longer to actually be confirmed. So it's become a little bit less viable for us to actually utilize. Ethereum is got much better bandwidth. We can actually go through transactions a lot faster, and the cost is a lot less. We recognized very initially that all of this could change over time. And in fact, with all the ICOs coming out, Ethereum's usage could actually change dramatically. We may have to utilize other ones. So we didn't want to be tied to any particular blockchain. That was part of the reason why we wrote a blockchain abstract layer that then writes to the different blockchains. Some of the clients that we work with, they want to utilize a permission-based blockchain, especially in the financial industry. So we also support that for cases where they want to do that. What's important about writing to a blockchain is that when you write to it, if we've got a lot of records that were initially written to Bitcoin, we actually continue to write Bitcoin as well, but you could just completely switch off and only write, say, on Ethereum, but you don't have to migrate old records over. And the reason for that is because the records are immutable. Once you write a certification, that certification is good on that blockchain for as long as you'd want to keep it. And we have a process for being able to relate that then to the new blockchain if we actually do a switch. But that's ultimately the process that we follow with that. So to that end of it, not only existing blockchains, there could be other blockchains in the future too that would be able to support. One of the other questions was that, are the blockchains working? Are we utilizing those? And I think there's a question about scale. And then do we use it as a proof of stake? And there's actually several questions within that. One is that we do use real blockchains, so we do write to public blockchains. We also utilize side chains. That's part of the architecture of how we use that. But ultimately, what we write to the blockchain is proof of work. On the side chains is where we actually write all the data, all the signatures, everything that we talked about. Then we hash that and we write the hash to the public blockchain, which becomes a proof of work for what it is that we've actually written on that. But that's how we actually utilize that. There's another question as to location. I think someone was asking where we could actually pilot this, whether we could do Europe or if it's just within the US. We have customers that are, certainly a number of customers that are here in the US. We actually launched a program with Credit Info, which is a European company, and they're actually a multinational company, so they provide support in different countries, both in Europe, North Africa, and Middle East. We just announced a program with BAJ, Bank of Al Jazeera, so that's in the Middle East. And we're also working with Japan. So our technology itself and the setup is such that we could work with just different regions. The blockchain is easily distributed and copied in different locations, makes it very easy to actually deploy and provide services multinationally. So it's not just within the US itself. If you have questions that you'd like to actually discuss in more detail, again, you could go to ShowCard.com, SHOCARD.com. And if you navigate that, you could both request a demo. You could actually send us an email and we'll be able to respond to that. If you want to download our SDK and utilize it, you can certainly do that. So there's more information there. And there are white papers that you could download, and there are some additional stuff if you contact us, we could actually share with you. I think at this point, we can end this session. I appreciate your time, but again, if you need more information, just go ahead and reach out to us. Thank you very much, and have a great day.